Okay, fourth period. I have now the paper that's going to eventually go on the page 83. This is just some practice with finding some definite integrals. You'll notice that the problem you're given here is not labeled, but this function is the function f of x. Okay, this function is the function f of x. And what you probably, or I hope you'll notice, is that this function f of x is made up of nothing but some line segments, and then one like semicircle. Okay, so it's going to create some areas between the function and the x-axis that we can calculate. And whenever I'm given a problem like this, I think sometimes it helps to maybe go ahead and do that first. So I'm going to take a second here and try and calculate some areas that I think will be helpful. And I might just start over here and point out that I can find the area between the function and the x-axis for this little bitty, looks like it would be a triangle between -4 and -3. If you remember, the area for the triangle is half of the base times the height. Since the base has a length of 1 and the height is 1, this area should be half of 1 times 1, which is a half. Don't worry about positive or negative. We'll deal with that when we encounter it, depending on which direction we're integrating. Okay? I'm just listing out what the areas of each section are. I see from 3 to 2, I see a triangle, a very skinny triangle, that would be 1 unit wide and 1, 2, 3, 4, 5, 6 units tall. So between -3 and -2, this area is half of 1 times 6, so that area would be 3. Again, I'm not worried about the positive or negative sign. I'm just trying to calculate some areas. To get the stuff between -2 and 0, I think it might help to break that region into a triangle and what I believe is a square. So I would say that this triangle here is half of 2 times 4. Half of 2 times 4 is 4. Okay, so this part is 4. This square is 2 times 2. That's 4. Okay. And if you actually want to, what I think I'm going to do, I hope you didn't do it in pen, is I think I'm just going to erase the lines I made now to calculate all of that, and I'm going to say all of that area from -2 to 0 is 8, the sum of the two. Okay. I've got a rectangle between 0 and 1. Right there. It's a 1 by 2 rectangle. That area ought to be 2. I have a triangle between 1 and 3. That would be half of 2 times 2, which is half of 4, which is also 2. So that triangle is area 2. Between 3 and 4, I've got another one of those half of 1 times 1 triangles. So we'll call that a half. Between 4 and 6, I have a triangle that is half of 1 times 2. That's just 1. And oh my goodness, looky here, I have half of a circle. So this circle would have a radius of 2, because the diameter of that circle would have been 4. So the radius is 2. The whole circle would be pi times the radius squared, and the radius is 2. So 2 squared is 4. That whole circle would be 4 pi. But since I only have half the circle, I'm going to call that 2 pi. So all of this is 2 pi. Now that might seem like a waste of about 3 minutes of our time, but I promise you that's going to make the work we have in the rest of this problem pretty easy to pull off. Okay? So what we're going to do is we're going to pause the video for about a minute or so, and if you need to talk at your table about how some of the areas were calculated, you should do that. Try to make sure everybody is on board with what the areas were before we move on. Try to help each other out. If you can't figure it out, I promise I will touch base back with this on you next week. So we're going to pause the video now for about a minute. give you a chance to talk about the areas and make sure we are all ready to move on. Okay, now that we are comfortable with some of the areas, let's try to find some integrals. Okay? Guys, we're going to find our very first definite integral. We want to find the integral from 0 to 1 of f of t dt. I want you to understand, for reasons that I'll tell you more about next week, that it's okay that I chose t instead of x. It doesn't change anything about how you calculate this area. We kind of call that a dummy variable. You would calculate this the same way if I wrote f of x dx, or f of u du, or f of a dA. It calculates the same way. But to calculate the area from 0 to 1, I'm always going to start at the lower limit. So I'm going to start at 0. Right there, I'm going to start at 0. And I'm going to travel this way, and I'm going to calculate until I get to 1, where my pencil's at. And I remember that when I'm traveling right, area above the axis is positive, and area below the axis is negative. And what I hope you can see is that between 0 and 1, the area is 2, and it's a positive 2. Guys, that's it. That means that the area, the integral from 0 to 1 of f of t dt is 2. So let's compare that then to the one over here. We want to find the integral from 1 to 3 of f of t dt. So now I'm going to start at x equals 1. And I'm going to stop when I get to x equals 3. And since I'm going to the right from 1 to 3, area above the axis is positive. And we calculated this area to be 2. So the integral from 1 to 3 of f of t is 2. Let me model another one for you. Let me model negative 3 to 6 of f of t. So here we're going to integrate from 3, starting at 3, and stopping at 6. Okay? From here to here. I'm traveling to the right, so area above the axis is positive, area below the axis is negative, and what you'll see, I hope, is that all of the area that I need to calculate this time is negative. So I'm going to calculate that total area. I've got a negative 1/2, I've got a negative 1, and altogether that adds up to negative 1/2, or negative 3/2. Negative 3/2. The next one that I need to find is the integral from 6 to 3. And I've got 2 ways to work that one. You think you know it already? Well, if you were going to calculate it from the graph, you would need to look back at the graph and then say we're going to start at 6. And we're traveling to the left now until we get to 3. So when you're calculating from right to left, the area below the axis is positive, and the area above it is negative. So now for this integral, I'm counting this area as positive. I've got a positive 3/2. Now another thing you could do here is that you could use that property of integrals that says if you switch the order of the limits, like we did from the one we just worked to this one, you would change the sign of the value. Either way you slice it, you're going to get positive 3/2. Let me do a couple more of these, and then I want you guys to pause, and we'll have you try a few of these. Let's try from 0 to 6 of, notice the negative there. I want you to remember that when you're calculating an integral and you have a constant in front of the function, you can pull that constant out. So let's take a minute to do that. Let's say that this integral is the same as the opposite of the integral from 0 to 6 of f of t dt. I'm using that property of definite integrals from page 84 to pull that constant out. So I need the area from 0 to 6. So let's go back to the graph. So now we need the area starting at 0 and stopping at 6. Okay? So when we go from left to right, above the axis is positive, below it is negative. So I'm going to start adding up. I've got a 2. I've got 2 more to make 4. I'm going to take away a half because this one is negative for 3.5. And I'm going to take away 1 more for 2.5. That integral should be 2.5 or 5 halves. But I can't forget that negative sign. That negative sign makes this negative 5 halves. Another thing you could have done there would have been to use that property that lets you flip the signs and rewrite this as positive integral from 6 to 0, and that would have gotten you there as well. Let me do one more where I'm steering, and then I'll let you guys take the wheel. Let's do the integral from 6 to 10 of f of t. Okay, from 6 to 10. So from 6 to 10, we're going to start at 6. And we're going to stop when we get to 10. So I'm traveling right. The area above the axis is positive. How about just that semicircle? How about 2 pi? How about 2 pi? Okay, here's what we're going to do. We're going to pause the video now, and I want you to take about 4 or 5 minutes and see if you can calculate all 6 of the remaining integrals very carefully. I want you to work together, okay? Don't be afraid to make a mistake, guys. As we, mistakes happen as you learn, okay? So we're going to pause the video right now, and I'm going to actually fill in the answers, and when we come back together, we'll talk about what happened. Boom! I just magically made my answers appear. So real quick, and not guaranteeing I didn't make any mistakes, we'll check through them. I think I've got it pretty cold, though. How did you do? Did you get the same answers I've got? I was hoping that maybe this one on the bottom left was the easiest one for you to find. Because there's a property of definite integrals that says if you integrate from some number to the same number, you're going to get 0. I think I can show you on the graph why that's true. If you start integrating at -2, but then you stop at -2, well, there's no area that's accumulated between the arrow and my pencil, is there? Yeah. The width is like 0, so 0 times 6 is 0, you know? Yeah. We had the integral from -3 to 0. -3 to 0 goes right here. So you would simply need to add the 3 and the 8 to get 11. When you integrated from -4 to 4, now we're over here to here. Okay. So the areas below the axis are negative. So you got a -1/2 and a -1/2 to make -1. You would add -1 to this 2 and this 2 to get 3. Plus 8 is 11, plus 3 more is 14. The -4 to 10 can be tricky because there's a lot of area to cover. And what to do with that 2 pi is tricky. It's totally okay for an answer like the one here on the integral from -4 to 10 to leave that in terms of just 13 plus 2 pi. In fact, I kind of think that's better than trying to give me a decimal value there, 19.28, something crazy. Okay. So pi is okay. In terms of pi is all right. I want to talk through briefly, as my video time is about to run out, this last one here. When you integrate the absolute value of f of t, you want to think about the whole curve going above the axis. The issue here is that this part of the graph that's below the axis would be above the axis on the absolute value. So you may want to sketch it out that way for that problem. But the reason that those are negative is that I'm integrating from right to left, from 10 to 3. So all of the areas I would count, the 2 pi and the 3.5 here, would have to count negative. Okay. So this video is about to come to an end, and we're going to show you the right half in the next video.